Record. All right. Good morning. Back to pre-calculus. We are talking about our practice final here, and I think I have the rest of these things written for us, so I will post these before too long. And let's see here. Why don't we do an easy one? Why don't we go ahead and do part C here, and then we'll move on to some other stuff. Okay. So we're going to do, okay. And again, you're not getting A, B, C, D, and E out of this, okay? You're getting 1, I'm picking 1. 3x squared minus 10x plus 3. Is that our spot here? It sure is. Okay, so here's my original function. Okay, so what we're going to do here is we're going to tone down the thickness of our line. Okay, so we're going to have a 3x plus h squared minus 10x plus h's plus 3. This is the f of x plus h part, minus, okay. And then we have 3x squared minus 10x plus 3, all divided by h. Okay, so just as a thought, right, here is, that didn't change colors. Okay, so this here, this is f of x plus h, this is minus f of x. Okay, so we have all the pieces sitting here. All right, first thing we have to do is we have to FOIL this thing out. I'm going to do this in one step, assuming you guys can do that. So this is going to be x squared plus 2xh plus h squared minus 10x plus h plus 3. Okay, minus 3x squared minus 10x plus 3, and this is all over h. Okay, so now we're going to FOIL, or not FOIL, we're going to distribute. Okay, so I like to do all the distributing on one spot, because if I don't do it that way, I tend to mess part of it up. I tend to forget one, so that's why I'm trying to keep all my steps in the same spot. So this is going to be 3x squared plus 6xh plus 3h squared minus 10x minus 10h plus 3 minus 3x squared plus 10x minus 3. You see that? The minus sign has to be distributed to all the places as well. This is the biggest error that students make, provided they get to this step. Okay, if you got to that step, this is the mistake you're going to make right there. Okay, so let's see here. We have what is that one? So we have a negative 3x squared and a 3x squared, right? We have a minus 10x and a plus 10x. We have a plus 3 and a minus 3. What do we have left? Okay, so here we go. We have 6xh plus 3h squared minus 10h, and the rest of the stuff is all gone. Now, the next common mistake, provided you got to this point, is that they cancel the h's here and forget about the other two. Don't do that. So that's h, 6x plus 3h minus 10, all divided by h, because I think it's safer to factor them out rather than trying to cancel. So we'll just cancel once, and our answer is going to be 6h plus 3h minus 10. All right, so that's pretty straightforward difference quotient for polynomial, for a quadratic specifically. Now let's go down to part 2, okay, where it's going to say, well, this is part C. X is -1, h is 2. Okay, so we have x is equal to -1, h is equal to 2, or a is equal to -1, b is equal to +1. Okay, so here we're going to say this is f of b minus f of a divided by b minus a. Here we're just going to use this equation here. Okay, this is going to be 6x plus 3h minus 10. Okay, so let's see what happens here. We're going to say 3 times 1 squared minus 10 times 1 plus 3 divided by, oops, so that's my f of b, minus 3 times negative 1 squared minus 10 times negative 1 plus 3. Okay, and this is all over, right? 1 minus negative 1. Okay, pretty good. So plugging in here, we have 6 times negative 1 plus 3 times 2 minus 10. So here it looks like we have negative 6 plus 6 minus 10. Looks like we're looking at minus 10 here. Let's see if we're going to be okay with the arithmetic over on the other side. Okay, so this is going to be 3 minus 10, right, plus 3, okay, minus, and we have a negative 3, right, that's, oh no, it's positive. It's negative 1 squared will be positive, okay, plus 10, yeah, that's negative 1. So negative 10 times negative 1, and then plus 3. Okay, and this is over 2. So let's see what we have. We have 3 minus 10 plus 3 minus 3 minus 10 minus 3 all over 2. So again, some stuff cancels. Okay, so we have a 3 and a negative 3. We have a 3 and a negative 3. We have negative 10 minus negative 10. So that's going to be minus 20. Oops. Back to blue here. So we have minus 20 all over 2, which is minus 10. Hey, what do you know? We did our arithmetic right. We got the same answer. And again, the reason we got the same answer is because both of these expressions are telling us the slope of the secant line between these 2 points. Okay, so they're just alternate expressions for the same thing. All right. So let's see here. Let's jump to number 5. Okay, let's jump to number 5. So let's see here. We have, what are we doing here? We have ln x squared minus ln x to the 5th equals negative 4. Great. Ln x squared minus ln x to the 5th equals negative 4. Well, the first thing we're going to do with this is we're going to make some kind of sense out of it. So we're going to say this is ln x squared minus 5 ln x plus 4 is equal to 0. Okay. Now it's important to remember that ln x squared is not the same as ln x squared. Okay. This says find the natural log of x and then square it. This one says find the natural log of x squared. Okay, so we're going to take the x, square it, and then plug it in. Okay, so let's try it with something like, hey, if I want to do the natural log of 6 squared versus the natural log of 6 squared, which is 36, isn't it? Okay. Don't put 0 in, you'll get the same answer. Or not 0, but don't put 1 in, you'll get the same answer. Okay, so when you're testing these things out, don't pick 0, 1, 2, negative 1. Pick numbers that are, you know, that are far enough away from 0 so you can, you know, you're gonna see what's going on. Okay, so we have natural log 6. Okay, enter, and then we're going to square this number. Okay, beautiful. This turned out to be 3.21. Some change, and then we're going to test out natural log 36 because that's 6 squared, and we got 3.58. So they're close, but they're not the same thing. Okay, the further away from E we're going to get. Okay, so if I put in E here, right, we're going to get natural log of E, which is 1. 1 squared is 1, versus the natural log of E squared, we're going to get 2 times natural log of E. 2 times 1 is 2. So here we get 1, here we get 2. So they are different numbers. Okay. So what I'm going to do now is I'm going to say let U is equal to natural log x. That would mean that U squared, right, would be natural log x squared. Please don't do this on autopilot. these u substitutions doing this stuff. It's a really common technique in the calculus, and once you've made a u, once you've made a substitution, follow it through and let the consequence, right, of what happens be the consequence of what you've picked. Don't just say, well, I need a u squared, so that's what I'm always going to just assign it. Like I've seen students do that. It does not work out well. Okay, so we have u squared minus 5u plus 4 is equal to 0. I'll bet I could factor this. That's going to give me a positive 4. It's going to be minus 1, minus 4 is minus 5. Okay, so we have u is equal to 4, or u is equal to 1. What was u? Well, u is the natural log of x, wasn't it? All right, so what we're going to do is we're going to unlogify this. So we have e to the natural log of x equals e to the 4th. E to the natural log of x is e to the 1. Are we done? No, we are not. We have to go back and look at what's the original format, right? And does this work in the original format? So if x was e to the 4th, well, if I plug in e to the 4th here, that's a positive number, right? Natural log of e to the 4th is positive. Natural log of, or I shouldn't say it that way. It's natural log of e to the 4th, positive, squared, still positive. Natural log of e to the, of e to the 4th raised to the 5th, which I guess is like e to the 20th, okay? That's still a positive number, so we're going to be okay. If I plug in just e, right? Natural log of e, that's positive, we're okay. Natural log of e to the 5th, that's positive, we're okay. Okay, so we're taking natural logs of positive numbers, checked. Both of these are reasonable answers, so our solution set, right, is e to the 1, e to the 4. Okay, done. You have to check on these, okay? If it's a logarithm in the equation that's given, you have to check. If you don't check, it's an automatic 1 grade deduction. Okay, so I mean, if you don't do it, I don't like give you like a negative F. That's not good, okay? But if you try, if like I had the right answer, but I didn't check, it's B. Okay. But it's right, it's still B. Okay. All right, more interest parts. Okay, so here we have Doc Brown. So if you're Back to the Future fan, upon realizing he is trapped in the year 1885, decides to open a bank account that pays an average of 3% interest compounded continuously for the next 100 years. Okay, forgive me, it's a math problem. We're making some allowances here. Since Doc Brown knows he will need some funding to pay off a debt to some terrorists, Back to the Future 1, he will have to have $1 million on hand to cover his debt, or in a good escape to buy some body armor. A lot of spoilers in this problem. Okay, sorry. How much will he have to invest in 1885 to have $1 million 100 years later? If he only had $10,000, how long will it take for this deposit to reach $1 million? In all cases, assume the bank exists for the duration of the problem. It's always a risk you take with the time travel, isn't it? Okay. All right, so we have R, A is equal to PE to the RT, right? That's our continuous interest problem. You're supposed to memorize this, remember? Okay. So what's the first one? How much will we have to invest in 1885 to have $1 million? So we want $1 million here, right? This is part A. How much is he investing? We don't know. I don't know what the principal is. We have E to the 0.03. Remember to change that to a decimal place. That is the biggest problem that people get. Okay. Times, and the time is going to be 100 years. Okay. So if I didn't know better, I'd say 3 pennies times 100 would be E to the 3 times P here. That's a P, not a question mark. Is equal to 1,000,000. And if we divide both sides by E to the 3, okay, we're going to get our principal. Come on. Okay, our principal is equal to 1 million divided by E cubed, which is we're going to need a calculator that. We're going to round to pennies if we can. Okay. So we're going to say 1,000,000, that's $1 million divided by second function ln. That'll give me e to the 3. All right. And then equals, and what do we end up here? We end up with 49,787.0607. Okay. Yes, the pennies actually do count because it's a long time. We're compounding over that whole time. So that'll actually be a difference. Okay, so I know that's a lot of money to get in 1885 too, but $1 million in 1985 is also hard to come by. Okay. I wonder if it even beats inflation. I don't know. All right, part 2, right? If he invests $10,000, right? How long until it doubles? All right. So let's see here. Right. So we have an amount is equal to P e to the RT. Same interest rate. So we're going to have, oh wait, was that? How long until he has 10 million, right? That was the problem. Not doubles, 10 million. Or 1 million rather. All right, that's better. So if he has 10,000, how long will it take until he has 1 million? So we have 1,000,000 is equal to 10,000. Okay. E to the 0.03 times 1. Oh, we don't know. Can't say it's 100 years. I don't know how long it's going to be. T. All right. So the first thing we're going to do is we're going to divide both sides by 10,000. Right, 10,000, not 1,000. Okay, we can just start canceling some zeros here. Okay, it looks like I've got 100 left. All right. So that is equal to e to the 0.03t. Well, now we've got a variable in the exponent position. And how are we going to get that down? We're going to take a natural log of both sides. So this business here, that'll come down in front. So we have 0.03 times t. ln of e, which we know is 1, is equal to the natural log of 100. So the next thing we're going to do is we're just going to divide both sides by 0.03. All right, it should be like 300, right? We're going to get t is equal to the natural log of 100 divided by 0.03, and we'll see what that is. Natural log 100 divided by 0.03. Oops. There we go. And 153 years. Okay, so not quite in time for that 100 years, but if you can manage to put everything off for another 53 years, then we'd be set. Okay, so I really want to call your attention to this. This was 3% interest, which is relatively high by today's standards, and it took this long to get 10 times your money. The biggest mistake people make with this is that they put 3 in here instead of 0.03, and then they get ridiculous answers. Okay, so I just want you to realize that these really are the formulas the banks use, that credit card companies use to figure out what interest is and to figure out what's going on here. So if you're turning $3,000 to $10,000 in the matter of like 3 years, like you can't do that. Okay, I mean, not legally. All right, you're not doing that. So if you get these insane, like I doubled my money in 3 years kind of stuff, like stop. That doesn't happen. Go check the most common mistake people make. Okay, So don't tell me something like that. All right. Because I really do. I mean, it's like you made the mistake of putting the wrong number in here, and then you compounded your mistake by looking at your answer and saying, well, that looks perfectly reasonable. Like, have you lived in this country for the last 20 years? Do you know, like, banking at all? Like, and I know a lot of you don't. You don't, you're young and you don't have a good, you haven't done this very often. But anytime you're like, hey, I doubled my money in 3 years, like, just realize like that is too good. If somebody says that to you, I could double your money in 3 years, you should probably run away from that person, because that's a scam waiting to happen. Okay, it's just not, that's not realistic. So, pay attention to answers on stuff like this one. Okay, how about number 6? We'll do a partial fraction. Okay, guarantee you, partial fraction. You're going to be using this in Calc 2. You're going to need it. Okay. So, as a matter of fact, I often go to Calc 2 parts of calculus books and steal their partial fractions for you guys. So, x squared plus 4 divided by 3x cubed plus 4x squared minus 4x. Uh-oh. We've got an x common to everybody. So if I'm going to factor, right, we have to factor. 3x cubed plus 4x squared minus 4x. It's going to be x, 3x squared plus 4x minus 4. Okay. So the next thing we're going to do is we're going to look at this and we're going to say, you can check it first. Okay, I kind of messed you guys up on the last problem. We could always check to see if b squared minus 4ac is greater than 0, right? The discriminant. And if it is, then we know we're going to have two solutions here. So we could say this is 16 minus 4a is 3 and c is negative 4. So we're going to have 16 minus a minus, so that's a plus. And we're going to have, what is this, 12 times 4 plus 48. I'm pretty confident that 16 plus 48 is a number greater than 0. Okay. So you could continue here and use quadratic formula to actually get an answer. Okay, I'm just going to go ahead and factor this. So we have x, we have 3x squared plus 4x minus 4. Take our 3 times our 4. Right? It's called the AC method. 3 times 4, that's equal to negative 12. Can I come up with two numbers that multiply out to negative 12, but add up to positive 4? And if we don't know, right, you could say, well, that's 1 and 12, it's 2 and 6, that's 3 and 4. That's all the things. So, well, I need a positive one over here, so this one's going to be, the smaller one's going to be negative, the bigger one's going to be positive, right? Because 6 minus 2, hey, 6 minus 2 is 4. I think we got it. Okay, was it a possibility of getting another one? No. Okay, so 2 and 6. So we're going to say this is 3x squared plus 6x minus 2x minus 4. See, that's 6 minus 2, that's 4. And then we're going to say this is x, and then we have a 3 here, right? 3x. What's left? We have x plus 2, yeah? Minus 2, pulling both the negatives out, we have positive. Change the sign because we pulled the negative, plus 2. This number and that number, those are the same. Those factors are the same, so we can say this is x plus 2, 3x minus 2. Okay, that's the factored form. All right, next step. So we have x squared plus 4, right? That's our problem, x squared plus 4 over x plus 2, 3x minus 2. Okay. I mean, technically, when you're done with all of this, your next step is you're going to do calculus on this. So if you're not reasonably quick at doing this stuff, I hate to say it to you this way, you're going to die of old age by the time you get done with your calculus problem. Okay, so we're trying to get you to be a little bit faster with some of these, so it's not going to take quite as long. Okay, so we're gonna multiply by the common denominator. Okay, so we're going to have a x plus 2, 3x minus 2, plus b, then we have an x, right? And then 3x minus 2, and then plus c, and then we have x plus 2, and that's equal to x squared plus 4. Okay. I'm going to go ahead and do this the long way rather than the short way. If you wanted to replace your x by negative 2, negative 2, negative 2, negative 2, negative 2, and then solve for b and c, you can kind of do that, okay, because things are going to cancel out. But let's go ahead and do it this way. So we have a, what is this going to be? 3x squared, 6x minus 2x, so that's going to be positive 4x minus 4 plus b, and then here we have a 3x squared minus 2x, right? C, and we have x squared plus 2x. Okay, that's equal to x squared plus 4. Okay, now what we're going to do is we're going to equate coefficients. Okay, I'm going to pull all the x squared stuff together. We're going to have a 3a. We're going to have a 3b. We're going to have a c. Okay, because the coefficient here was a 1, it was 3, it was 3. And this is going to be equal to 1. What about x? Okay, so we're going to have a 4a minus 2b plus 2c. That's equal to 0 because there wasn't a linear term over here. All right, I don't think there was at the very beginning. Yeah, I know. All right. Yeah, no x terms over there, so there's 0 of them. Okay, and here's my constant. Okay, and this one's kind of nice because we have negative 4a's. Oops, I'll put it over here, negative 4a. This one didn't have a constant term, right? There is no constant term with b. There is no constant term with c. So that equals 4. I think we could pretty much conclude here that a is equal to negative 1. Okay. Look for stuff like that. It's not my intention to give you a long factoring problem and follow it up with a long solving equations problem. Okay. So if I plug in the negative 1 here, right, we get negative 3 plus 3b plus c is equal to 1. So we're going to add 3 to both sides. So we're going to get 3b plus c is equal to 4. Plug it in over here, we're going to get negative 4, right, because a is negative 1, minus 2b plus 2c, okay, equals 0. So let's do one step here. We have minus b plus 2c is equal to 4. I added 4 to both sides. Can I do something like this and say negative b plus c is equal to 2? Negative b plus c is equal to 2. Now you're down to 2 equations, 2 unknowns. There are as many ways as there are days in a week to solve this thing. Actually, there's more than 1 days in a week to solve it. So use whatever method you would like to use. I'm going to multiply by negative 1. So we have 3b plus c is equal to 4. And a negative 1 is going to be b minus c is equal to negative 2. Add them. 3 plus 1 is 4b. Okay, that cancels, and we have 2. B is half. Okay, and now the last thing we're going to do here is we're going to pick any, where are we? Pick any of these 2 equations. Plug in for a and b, and then we're going to solve for c. I'm going to use the middle one because since I know b is half, right, or negative half, No, it's a half. I'm going to multiply it by an even number. Okay, so we have, you can use one of these two down here that we did. We'll say 4a minus 2b plus 2c is equal to 0. Okay. 4a minus 2b plus 2c is equal to 0. Make sure I got that right. We sure did. So we have negative 4 minus 2 times a half plus 2c is equal to 0. So minus 4 minus 1. Negative $4 in debt, you spend another $1, now you're $5 in debt. So 2c is equal to 5. C is equal to 5 halves. Okay. So our answer here, okay, this is equal to negative 4 over x, okay, plus 1 half. 1 over, what was my b term here? B was x plus 2. You're going to put the 1 half over here, that's fine. Okay, it means the same thing. Okay, you could say 1 half over x plus 2. This always confused me a little bit when I got to calculus, so if I just threw it out in the front, it was a lot easier for me to see it. But you know, they're both equivalent, so it's fine. All right, and then the last one, c was over what? What was 3x minus 2? Okay, so this is going to be plus 5 halves, and then 1 over 3x minus 2, or, you know, 5 halves over 3x minus 2. There's our answer. All right. So that's how you do partial fractions. Again, if you end up with like 3 equations, 3 unknowns, you're like, oh, I got to slog through this matrix. One, double check your instructions, because final exam, I do not need to be doing a problem that's going to be that long. 2, make sure like you know, you didn't accidentally end up with like an a equals negative 1 kind of situation, right? Because the goal here is not to make really long problems. The goal here is to see if you know how to do it. Okay, so I think we're going to stop there. Okay, for doing the rest of this. Speaking of making really long problems, I think I'm going to have to edit some of these. It's probably too much. So I'll post them, but on your actual final exam, there might be a much smaller set of things you have to deal with here. Same with this. The reason why they're listed like this is I pulled them out of the book. Okay, I pulled them out of your homework problems. So 8 and 9, okay. 10, not too bad. Okay, 11 and 12, I'll try to do something with those. Okay, these seem to be relatively tame to me. Okay, but that's a good set of 12 problems. Okay, so I will see you tomorrow, and till then.